So let's discuss frequency distribution. Now, frequency distribution is the grouping of data into mutually exclusive categories, showing the number of observations in each class. So to create our frequency distribution table, the first step is that we need to divide the result into intervals and count the number of results in each interval. The second step is to make a table with separate columns for the interval numbers, the tallied results, and the frequency of the results in each interval. The third step is to record the number of observations in each interval with a tally mark. And the fourth step is to add the number of tally marks in each interval and then record them in the frequency columns. So in this representation, we have a number of 0, 1, 2, 3, and 4. Then we have our tally marks, and then we have our frequency. So an accumulative frequency distribution table is more detailed than a frequency distribution table. First step is to the frequency distribution table, add 3 more columns for the cumulative frequency percentage and the cumulative percentage. Step 2 is in the cumulative frequency column, the cumulative frequency of the previous rows is added to the current row. The third step is the percentage is calculated by dividing the frequency by the total number of results and multiplying by 100. And then the last step is that the cumulative percentage is calculated similar to the cumulative frequency. So for the following data set, the cumulative frequency distribution table is given: 37, 49, 54, 91, 60, 62, 65, 77, 67, and 81. This will allow us to have a lower value and upper value, the frequency, the cumulative frequency, the percentage, and ultimately the cumulative percentage. Now, a stem and a leaf plot is used to present data in a graphical format to enable visualization of the shape of our distribution. So for example, the following are the temperatures for the month of May in Fahrenheit. Now, to create the plot, all the 10 digits are entered in the stem column, and all the unit digits are entered in each of the 10 digits are entered to the leaf column. So in this particular case, all of our temperatures are in the 50, 60, 70, and 80 degree range. So we know that the first digit would be 5, 6, 7, and 8. So those numbers are placed within the stem column. All of the 10-digit numbers, which could range anywhere from 0 all the way up to 9, would be placed in the leaf based upon where they fall in the stem. So for instance, we will have a 51 degree, a 58 degree, and a 59 degree, or a 62, 64, 65, 67, 68, and 69. And we just count how many times that happens. So still speaking around graphical methods, let's talk about box and whisker plots. So a box or whisker graph is based on medians and quartiles. It's used to view the data distribution incredibly easily. So for example, the length of 13 fish caught in a lake are measured and recorded as follows: 12, 13, 5, 8, 9, 20, 16, 14, 14, 6, 9, 12, and 12. The first step that we have to do is rewrite all of our data into increasing orders. So it starts at 5 and ends at 20. Then we're going to find the median of our data set. Remember, our median is the center point in all of our data. This will allow us to find the lower and the upper quartiles. So we know that the lower quartile, or lower 25%, is around 8.5 because our median is 12. And the upper quartile is going to be 14. So then step 4 would be that we need to draw a number line extending enough to include all of our data points. Step 5 would be to locate the main median, which we know is 12, using a vertical line. Then we'll locate the lower and upper quartiles, which we identified as 8.5 and 14, and join them with the median by drawing boxes. Now the next step is to extend our whiskers from either end of the boxes to the smallest and largest numbers, which in this case was 5 and 20 within our data set. Now the following inferences can be drawn from the box or whisker plot. We know that our range is equal to 20 minus 5, because our range is always our maximum minus our minimum. So our range is 15. Now the quartiles split that data into 4 equal parts. So there's numbers that are less than 8.5, there's numbers between 8.5 and 12, there's numbers between 12 and 14, and then there's numbers greater than 14. So a scatter diagram can be used to understand the correlation between two variables. It can help us examine cause and effect relationships and identify the root cause. Now there are 5 types of correlations. The first one being a perfect positive correlation. Then we have a moderate positive correlation. Then we'll have no correlation. And then we'll have moderate negative correlation and a perfect negative correlation. Now in perfect positive correlation, as the value of x increases, the value of y also increases. So for example, there is a correlation between consumption of coffee and the consumption of milk, as listed by this example. In a moderate positive correlation, as the value of x increases, the value of y also increases, but not in the same proportion, as listed here with our correlation between monthly salary and monthly savings. Now, when a change in one variable has no impact on another, then there is no correlation between them. For example, in this graphic, we see the relation between the number of fresh graduates and job openings within a city. Now in moderate negative correlation, as the value of x increases, the value of y decreases, but also not in the same proportion. For example, the correlation between the price of a product and the number of units sold is a great example. Now in a perfect negative correlation, as x increases, y is going to decrease proportionally. An example would be between project time extension and project success. Another graphical method is a histogram. A histogram is similar to a bar graph, except that the data in a histogram is grouped into intervals or units. A histogram is best suited for continuous data. So for example, the number of hours spent by 15 team members on a special project within a week. Another graphical method is the normal probability plot. Now, normal probability plots are used to identify if a data set is normally distributed. A normally distributed data set forms a straight line in a normal probability plot. So, for example, the following data set that you see is of the diameters of a drilling operation. Now, step 1 is to construct a cumulative frequency distribution table and calculate the mean rank probability estimate using the formula below. Now, after performing step 1, the mean rank probability estimates are then calculated, and this table will list all of them. Step 2 is going to plot the graph on a log paper or possibly using Minitab, which is a statistical software used for Six Sigma. Now, if you are using Minitab, there are 7 steps to complete a normal probability plot. The first one being we want to paste the data into any one of our columns. Then we'll select the graph from the menu bar, we'll select the probability plot. Then we'll select the type of the graph, which in this case will be a single one, and we'll click OK. Then we'll double-click on the data column, and then we'll click OK again. In conclusion from this graph, it can be observed that the random sample forms a straight line. Therefore, the data is taken from a normally distributed population. Now, this concludes topic 4 in measure. We'll be back again in topic 5, where we'll discuss an MSA, or a measurement system analysis.